Algebra 1, Common Core, Unit 5, Section 1. Sorry, this says Chapter 4A video notes. I guess I never changed that. I like to use the same templates. This is 5A video notes. That's why we're starting with 5.1. And so we're getting into a chapter called Functions, and our first introduction here is on functions. What is a function? So we start off with some definition stuff. A relation is a set of ordered pairs. A set of ordered pairs of input and output values. We're going to talk more about this concept of input-output when we get into really the next video on evaluating functions. You kind of want to think of functions almost like machines, where you plug in something, you get something out. And that's really what equations are. Like when you have something like y equals 2x plus 3, if I plug in a number here, for x, I get a resulting number for y, and they're paired together as an input and an output. So we'll talk more about that. But for now, a relation is just a set of ordered pairs. It's just a set of two things. Now, what you see down here as the examples, these are ordered pairs because they're coordinates. It doesn't have to be numbers. I mean, we're going to work mostly with numbers just because that's what we do here. But the ordered pairs. Like it could be, apple, comma, banana, or I could pair, colors and numbers. It'd be 5, comma, red, 2, comma, blue, 6, comma, yellow kind of thing. It's just it's a set of ordered things, but we're going to work pretty much exclusively with numbers here. Now, the domain for these ordered pairs is the set of input values, and for coordinates, it's the set of the x values. It's the first thing in the ordered pair. So we look at our example down, our problems we're going to do down here, 3, 5, 7, 4, 6, 4. The first number or x value here is 3. This x value here is 7. The x value here is 6. The y value is 5. The y value is 4. The y value here is 4. Right, so that, this particular one, and what they want us to do down here is determine the domain. So the domain here, that's a pretty terrible letter. Let me do this a little bit better. I'll do a capital D with like a little subscript x. The domain for this set is 3, 7, and 6. Because those are all the first thing in the pair, right? This is a pair. 3 and 5 are paired together. The first number or first thing is the number 3. It's the x value of the coordinates because we know coordinates go x, comma, y, right? The first number is considered the x value. The second number is considered the y value. When we get into graphing, which is coming up in this chapter a little bit too, we get our x and y axes, and something like 3, 5. Well, that's our 3 on the x-axis, so like over 3, and then up 5 on the y-axis, so it'll be 3, 5. That's what we're talking about. Oops, let's rotate that. So that's your domain. Your range is your set of output values, the y values, the second thing in the pair. So our range, we do r of y, r subscript y, is in this case 5 and 4. Now 4 is repeated twice, but we only need to write it once. But 5 and 4. That's it. And then the next important word here is function. And that's actually what we're talking about, functions. Because these are all relations, but they might not all be functions. So a function is not just an ordered pair, a pair of ordered pairs. A function is it is a relation where no element in the domain repeats. And so if we look at our first ordered pairs down here, our domain was 3, 7, 6. Notice that no number in this domain is used more than once. So this would be yes, this is a function. What you see in the second example over here, first let me, I'll list my domain. My domain in this case would be 3, 7, and then notice that 3 appears again, a second time. The fact that 3 is appearing a second time, the answer here is going to be no. This is not a function because 3 is a repeated element, we call it, like, the things in these sets are called elements, or a repeated number, but it's a repeated thing in the domain. And the problem with this, the reason why it's not, again, if you think of that concept of machines, that when I plug in a 3 into this machine, I don't want to get two different things out. I don't want to plug in a 3 and get a 5, plug in a 3 and get a 4. That's not what a function is. More simple than that, where you plug in one thing and you get one thing out. Just to finish up this set here, the range here is 5, 4, and then 4 is repeated again. Now notice that there was no problem with 4 repeating in the range. Repeating in the range is okay, but repeating in the domain is not. So anything repeating in the range, that doesn't really mean much. You can plug in different things that become the same thing, but you do not want to plug in something to get two different things. And so it's all about repeating x values where no element in the domain, no x values are repeated. That's how we determine if something's a function. This next group of questions here, this little diagram thing is very similar to just a set of coordinates. Notice these are little arrows here, and it's showing that 2 goes to the number 1. So that's almost like the coordinate 2, 1. 1 goes to the number 5, 1, 5. And 3 goes to the number 3, so 3, 3. So our domain in this set is all of these first numbers. And our range is where they're all going. So our domain would be 1, 2, 3. Our range is 1, 3, 5. Is this a domain? Well, nothing here is repeated. 1 is only going to one spot, 2 is going to one spot, 3 is going to one spot. So yes, this is a function. Our second example is this is my domain and this is my range. But the answer here is going to be no, because you see that the number 1 is going to two different places. That would give you a coordinate of 1, 1 and 1, 3. So this is not a function. Still a relation, but it's not considered a function. And the same thing up here, that because 3 was repeated, it wasn't a function. Here 1 is being repeated in the domain, not a function. So we could see relation as a set of coordinates, as a little diagram like this, or it could be an equation like this. It wants the set of coordinates for y equals 2x minus 1 for the x values of 1 is less than or equal to x is less than or equal to 4. This right here, that's my domain. So my domain is the numbers 1, 2, 3, and 4. These are the x values that I want to plug in here. I got to figure out what the range is. Now with the graphing calculator, that's really simple. I could just type this into my y equals and then, see what I get for these. I'll do them real quick manually though. So, if I plug in y equals 2 times 1 minus 1, right? 'Cause my function is y equals 2x minus 1. If I plug in a 1 there, if I do y equals 2 times 2 minus 1, what do I get? Y equals 2 times 3 minus 1. Y equals 2 times 4 minus 1, right? Start at 1, end at 4. And these equal to bars mean we got to include 1 and 4 in those sets. And this is where you really start to see the concept of input-output. I plug in a 1, what do I get? Well, it'd be 2 times 1 is 2, minus 1 is 1. Here we have 2 times 2 is 4, minus 1 is 3, 2 times 3 is 6, minus 1 is 5, 2 times 4 is 8, minus 1 is 7. So again, my domain was the numbers, whoops, how did that move? 1, 2, 3, and 4. I should probably do that with a little squiggly there. My range, extend this page a little bit, my range was the numbers, everything's falling apart here. Oh no, my Y fell apart a little bit too. That's all right, go back. All right, my range was that outputs. We plugged in 1, 2, 3, 4. We got out 1, 3, 5, 7. That's meant to be a little squiggly there. And what happened? Is this a function? Did any of our x values repeat? We plugged in 1 once, we plugged in 2 once, plugged in 3 once, plugged in 4 once. So yes, this is a function. All right, this last example is given to us graphically. And before we do that, I want to go to the next page, because the next page is all about how to read domain, range, and function from a graph. So I'll come back to this in a minute. And so our next page, and I apologize if this is a little fuzzy here for you. Hopefully, maybe it looks a little better on your screen than mine. Probably not. So what this whole thing goes through, and this is a whole page of notes kind of explaining a couple of things here that, your domain and your range are still your x and y values, and I'll show you that in a minute. But to determine if something is a function, anything graphed on, let me use my highlighter here. Anything graphed on the coordinate plane is a relation because all graphs consist of coordinate pair x, y values, right? A graph is made up of coordinates, and coordinates are x, comma, y. To determine if a graph is a function, we use something called the vertical line test. And basically that means, like, here's an example. Here's a graph. Notice that because we can draw a vertical line that hits the graph in more than one spot, it is not a function. If you could draw a vertical line that hits it in more than one spot, it's not a function. Because if you could draw a vertical line that hits it in more than one spot, that means those points have the same x value. See here, like, again, it's a little fuzzy, but this is the point 30 and the point 34. They have the same x value. So that's really the key to that piece right there. And so for this, first of all, if I think about the domain here, it's how far left the graph goes. And this graph goes all the way over to -5. And how far right it goes all the way over to 4. So this is how I could write this domain. -5 is less than or equal to x is less than or equal to 4. Or if you want to use interval notation from the last chapter, that's -5, comma, oh, I said -5, but I wrote -4. Oops, less than or equal to 4. -5, comma, 4 with brackets. They are included. Notice that those were closed circles there. That's as far left as we go, as far right as we go. And then for range, and it's all the numbers in between, right? There's points at -4. There's a point on -3, -2, -1, 0, 1, 2, so on. The range is how low does this thing go? It goes as low as -4 and it goes as high as 3. So that would be -4 less than or equal to y less than or equal to 3. Again, you can do that in brackets if you'd like. So then the last question, is it a function? And is it a function? The easiest way to tell is just can I draw a vertical line that hits it more than once? Now, I mean, you don't have a line tool, but see how if I draw a vertical line here, it's only hitting this graph once, only hitting it once. But then when I get over to here, all of a sudden my vertical line is hitting it. It hits it once up here, once here, once here. It hits it multiple times. So that means there are coordinates on this graph that have the same x value. So this is not a function. Because there are, if you think of all the points on this graph, some of them have the same x values. And the vertical line test is how we could determine that. All right, so that's it for your introduction to domain, range, relations, and functions. We'll be evaluating functions in the next video. See ya.